Alright, now it's time to attempt another question regarding linear modelling. Now, like always, what we need to do when answering these questions is just follow these steps. So first step says highlight the key information in the question. So just get the highlighter out here. And it says rent-a-chef provides food cooked and served by a qualified chef at parties. The company charges $120. So remember, whenever you see a number, you're just going to highlight it, $120 as a booking fee. Right, that's basically saying the initial fee. And an additional $3 per hour. Remember, the word per basically means a rate, which means it's the gradient. Another company, Lightening, provides fast food served by 2 students at a cost of $65 per hour with no booking fee. Okay, so that's also meaning basically that there's nothing to start off with. And the question essentially says, under what conditions would it be cheapest to hire Lightening? So what conditions would it be cheapest to hire Lightening? So let's go through. We've now highlighted all the key information. The only other thing that is also of use is also knowing the name of the companies, because we're going to be comparing the two. So we've got Rent-A-Chef and Lightening. Alright, so highlight the key information. Next step is to identify the variables and write down in dot points. So the variables, well, we're going to be talking about cost and time, aren't we? Because it's talking about how much something is going to cost over how many hours you have them hired for. So we've got cost, and we're going to talk time in hours. Okay, we've done that. Assign pronumerals to these variables. Well, let's call cost C. Oh, let's call time in hours T. Awesome, flying through these. Alright, fourth step, identify the fixed cost and the cost per unit for each one. Okay, so let's go through the first one, Rent-A-Chef. So the fixed cost is $120 booking fee. That's your initial thing, because before you even get there, it's going to cost you $120. So initial or fixed equals $120. And the cost per unit, now remember the word per means it's a rate, and it means it's going to go out the front of the independent variable. So it means the cost per unit is equal to $30 for this one. Right, let's have a look also at the Lightening one.
Lightning! We'll get some overhead lifters and 4-barrel quads, oh yeah.
Okay, so the initial cost, well, they don't actually charge anything for them to come out, so the initial cost is actually 0. And the cost per hour, well, that's $65, or the cost per unit is $65. Okay, so now that we've done step 4, what we need to do is write an equation using the information to represent the problem. So let's come up with 2 equations for these 2 companies. So for Rent-A-Chef, we're going to have the cost, C, is equal to $120 before you even start, plus 30 times the number of hours, T. Right, and for Lightening, the cost is going to be equal to 0, well, you don't need to write that, plus 65 times the number of hours, T. Great, we've done that now. Now we need to use this equation to solve any given question that you may be asked. Now we might actually want to use 7 to help us out with this, and there's roughly sketching a graph may assist you in answering these questions. So let's just do that quickly. We're just going to sketch the graph. So let's make T equals 0 for each one. So you get C is equal to 120 plus 30 times 0. C is equal to 120 plus 30 times 0. Well, 30 zeros is 0, just $120. So the coordinate of that point is 0, 120. Right, for this one, T equals 0. Therefore, C is equal to 65 times 0. And then, of course, 65 times 0 is just 0. So the coordinate for this one is 0, 0. So that means after 0 hours it costs $120 for Rent-A-Chef, and after 0 hours it costs $0 for Lightening, which makes sense based on what you see in the question. Alright, let's just make T equal 1 for both of them now. So we get T equals 1. So we get C is equal to 120 plus 30 times 1. Therefore that's equal to 120 plus 30 times 1. 30 times 1 is 30. So 120 plus 30 is 150. This one here for T equals 1, you get C is equal to 65 times 1, which of course C is equal to 65. Alright, that means the coordinates for the Rent-A-Chef is when T is 1, you get an answer of 150, so it's 150. For this one here, when T is equal to 1, you get 65, so the coordinate is 165. Right, I'm just going to draw these out now. So I've got the first coordinate of 0, 120 here. So I've got the coordinate of 0, 120 here. and I've also got the coordinate of 150 here. I can join the two dots, making a linear graph. And then for this one here, do it in a different color for grease lightning.
Grease lightning!
We're going to have a 0, 0, 165. I'm going to join the two dots there. And if I continue this line on here, what you can see is it's actually going to cross over at a certain point. Okay, so the question says, under what conditions would it be cheapest to hire grease lightning? So therefore this one here is grease lightning, and this one here is rent a chef. So what we want to know is, for how long will it be cheapest to hire grease lightning before grease lightning becomes more expensive? Well, to do that we need to find the point of intersection between these two lines, and whenever we're looking for the point of intersection, what we need to do is use simultaneous equations. So let's write out these two equations. So you get rent a chef has the equation C is equal to 120 plus 30t. We'll call that equation 1. And we have grease lightning C is equal to 65t, and we'll call that equation 2. Right, now because we're doing simultaneous equations, let's have a look to see if any one of the pronumerals is on its own. So we have a look at this, and we get C is equal to 120 plus 30t. Of course, C here is on its own, so that means I can use the substitution method. So that means wherever I see the C down here, I can just write the 120 plus 30t here. So let's substitute equation 1 into equation 2. So you end up getting 120 plus 30t is equal to 65t. Right, let's get the t's on their own now by subtracting 30t here and subtract 30t here. These cancel out, leaving us with 120 equals 35t. Let's now divide both sides by 35. These cancel out, leaving us with t is equal to 3.4. Now the question is saying, under what conditions would it be cheapest to hire grease lightning? Well, essentially what that's saying is up until 3.4 hours is cheapest to hire grease lightning, because you can see that by the graph here. After that point it's going to be more expensive to hire them, and it'll be cheaper to hire rent a chef. Therefore it's cheapest to hire grease lightning up until 3.4 hours. After this point it is cheaper to hire rent a chef. And as you can see here, we've used the equation to solve the problem, and we've also drawn a graph to help assist us with answering this question.
Why, it's greased lightning! Greased lightning! We'll get some overhead lifters and 4-barrel quads, oh yeah. Keep talking, won't keep talking. Fuel injection cut up in chrome-plated rods, oh yeah. I'll get the money, I'll get the money. With a 4-speed...
What do you think you're doing? This is my math video. You can't just go and hijack it like that and just do what you want. Get out of here! Oh, I'll tell you what. Alright guys, thank you very much for tuning into today's lesson, which was all about linear modelling. Now hopefully you realise that this lesson is all about applying the skills that you've previously learned throughout the topic and using them when attempting wording questions. Alright, so make sure you stay tuned for the very next lesson, which is going to be in a new topic, all about quadratic functions. Like always, say hi to your maths teacher for me. Mozzie out.
Every day I'm shuffling.